everybody. All right, so we've talked about enzymes. Enzymes control all the chemical reactions in your body. Their shape is important because it allows them to attach to their specific substrate and cause the chemical reaction that you need to stay alive. Okay, now we're going to talk about the things that affect whether enzymes are doing their job or not. In other words, things that are really important to keeping you alive. Because if you change these, you change the shape or something about the enzyme and it no longer does its job, and then you die. So we don't need that. So we want to know what these specific conditions are that are really, really important in your body to keep right so that enzymes do their job. One of the most critical ones is temperature. Now, you know temperature is important. It's why you take your temperature to see if you're sick, right? When you're sick, your temperature's off. It's not the same as it should be normally. Part of the reason is that temperature is really important to enzyme function. And there's a certain range that's really healthy for us, right? We have 98.6 degrees Fahrenheit or 37 degrees Celsius is really good for you. Why? Well, your enzymes work really great at that particular temperature. There's some other reasons too, but that's a critical part of it. Another thing that affects how enzymes work is pH. Remember pH, right? How acid or base something is, right? And if it's 0 to 14, 0 to 7 is acid, 7 to 14 is bases, right? That pH is going to affect enzyme activity and so is going to affect how you function and whether you're alive. So that's another one. A third one we're not going to talk about, you can write it into your notes. It's how much enzyme and substrate there is. Essentially, if there's no enzyme, you're not going to have any enzymes doing anything. And if you have no substrate, the enzymes aren't going to do anything. And if you change the concentrations, they start to do stuff. But we'll leave that aside. That's enough said for that. I'm going to run through a little video for you, and you can see this animated, and then we'll talk about it in more detail. Okay, so we have the effective temperature. So we're going to start.
When enzyme and substrate molecules are mixed, they randomly collide, forming enzyme-substrate complexes. As temperature increases, so does the kinetic energy of the molecules, and therefore also the rate at which these collisions occur.
Okay, non-British accent, simplified. Enzymes bump into substrates. The warmer it gets, the more likely they are to bump into each other. The more likely they are to bump into each other, the more likely you are to have the enzyme work. Okay, so if it's very, very cold, enzymes aren't going to have a lot of activity. As it heats up, they're going to be more and more active. Okay, optimum just means best. And at this point, you have them bouncing around and those enzymes are bumping into substrates and they are causing reactions at a really good rate. Those enzymes are active, high activity, high temperature. There's a problem now. Once you hit the best or optimum temperature, something starts to happen. Look at those enzymes. That's the shape. Shape's important, right? Don't forget, shape's important because it determines if it can match up with its substrate. If its shape changes, it can no longer control the reactions. It doesn't work anymore. Well, look at the shape of these. It turns out that high temperatures cause essentially melting. It's called denaturation. It changes the shape of the enzyme. If the enzyme changes shape, can it do its job? No. And so once you get to that point, the activity of the enzyme is going to start to go down because more and more of them are denatured. Now you only have 2 working here. And so enzyme activity is low when it's cold because they're not bumping into each other. You get to the best temperature because they're really bouncing around, but the enzymes are still in good shape. Then it starts to get really hot and the enzymes start to change shape and no longer work.
The temperature continues to increase beyond the optimum. The enzymes begin to lose their three-dimensional structure and come to nature, therefore reducing the rate of reaction. To recognize the graph of the effective temperature in enzymes, it looks like this with the peak being the optimum temperature. To explain up to the peak, as the temperature increases, so does the kinetic energy of the enzymes and substrates, resulting in projected frequency of collisions.
In English, well, not British English, the enzymes will move around a whole lot more and bounce into each other. until you get to the optimum temperature. It's really bouncing. Then they start to denature. The warmer you get, the further you go on this axis, the warmer they get, the more and more of them denature and the less they work. Okay, pH is similar. Now remember, the shape of the enzyme is important. Turns out every enzyme has their perfect pH. They like their conditions. Not all enzymes like the same pH, but they all have a pH that they like best, and it forces them into a particular shape. So if you imagine that this is an enzyme and this is a substrate, right? And if at pH 4, it's in this shape, that means this enzyme would work best at pH 4, that particular acidic pH, okay? And as you change the pH, it might start to change shape and then no longer work. So the pH becomes really important. This one may only be able to work at 4 and fit its substrate. If you go down to 1, it won't work. If you go up to 8, it won't work. So it has its optimum pH, just like there was an optimum temperature.
Increasing pH values decreasing pH as a result of dust. Increasing potential of the enzyme, and this relates to the enzyme
She gave a lot of detail you don't need. Bottom line, pH will change the shape of the enzyme, and it has a perfect pH that it makes it the right shape to work on its substrate. That pH, where it's perfect, is its optimum pH. Optimum means best. Anything else is going to have low activity. So if you look down here, it's going to be low activity because it's a low pH, lower than its optimum. Right here, maybe this would be number 6, say. Then it would be 6 would be its optimum pH, and that's the perfect shape for it to do its job. As you go up in pH, it gets changes shape again, and it doesn't do its job anymore. So if you look at the graph for any enzyme activity, if you have enzyme activity on the y-axis and you've got temperature on the x-axis, there's going to be an optimum temperature. Below that, they don't bump into each other enough. Above that, they're the wrong shape. Same thing for pH. There's going to be a perfect pH that gives the enzyme its perfect shape. If you get too low, too acidic, it changes its shape. It won't fit to its substrate anymore. If you go above, it won't fit to its substrate anymore. And that is the factors that affect enzyme activity.